Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant from the Math Mastery Academy, and we are looking at question 24 from the 2023 Pascal contest from the University of Waterloo. This one confused a lot of people at Math League, and probably because it's wordy and you need to read carefully and and visualize as you read what's happening. So let's take a little bit of time here to really enter the problem together, and then we'll build a strategy. We'll solve it as best we can, and then check our answer by doing some review and trying to consolidate our learning as well. Okay, so we have cube A, B, C, D, E, F, G, H. Those are the 8 vertices of the cube. Has edge length 100. So put that on your diagram, okay? Just like improve your diagram whenever you get a chance. That's edge length 100, and they're all the same, okay? They're all the same because it's a cube. And then point P is on AB. I can see they put point P over there for me. I can see it. Okay, point P is on AB such that AP equals X. Well, put it on your diagram. This is X. All right, that's X units out there. X has got to be bigger than 0, but smaller than 100. Maybe it could be as big as 100, I don't know. But it can't go past B, okay, because it's between A and B. All right, AQ is X plus 1, so put it on there. All right, just put it on your diagram. X plus 1, okay? And AR is X plus 1 divided by 2X. Okay, so that's like going to grow, but really slowly, I guess, or shrink, or some weird. If X is very small, it's going to be actually pretty big. So this one down here is X plus 1 divided by 2X. Okay, so now we've got that all in our diagram for some integer X. For how many integers X is the volume of the triangular-based pyramid APQR? Okay, APQR. It's ugly to draw it on your diagram, so draw it here. And you can just kind of follow your diagram. There's A, there's Q, here's R up here, and then back here is P. Okay, and that creates, if you notice, a triangular-based pyramid. It goes back behind that. There's also line AQ PQ that connects those behind the pyramid, and it's really like a flat kind of not very tented up pyramid, but it's still a pyramid, okay? And we want to know for how many integers is its volume between this and this of the cube, how much of that percentage, okay? So first of all, let's find the volume of the cube. It's not hard. It's a million, okay? So the volume, so I hope we've entered the problem. We want to change the value X, which is going to change the dimensions of this pyramid such that it's about 0.04% all the way to 0.08% of the volume of the whole cube. So the volume of the cube is just the edge length cubed. That's not the number E. I've seen this formula written this way. I don't know. It's the edge length cubed, the psi s cubed, I guess. And in this case, that's 100 cubed, which is 1 million. Okay, so 0.04% of that would be 0.0004 multiplied by 1 million. And I'm not ashamed to say that I would just take away the digits here. So let's take away 1, 2, 3, 4 digits. So I believe that to be 400. I think it's 400. But now I just really want to check, because this is one of my weaknesses, is working with like lots of digits past a decimal place. I kind of get confused. So 0.0004, that's 0.04% multiplied by 1 million. Oh, there, equals 400. Good. Yes, okay, I was correct, which is pleasing to me because it's something that I get wrong a fair bit. So that's the lower bound that we're looking for, and the upper bound would be 0.0008 multiplied by 1 million, blah, 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 equals 800. Okay, so we want the volume of this cube to be between those two things. We want all the possible values of x that will do that. So let's set up some inequalities. 400 is less than the volume of the pyramid, which is less than 800. And they didn't give us the formula for volume of a pyramid. Okay, let's carry on. So they didn't give us the formula for volume of a cube. Oh wait, no they do. Yeah, the volume of a pyramid is equal to 1/3 of the area of its base times its height. Okay, so we can use that. I have that memorized, but maybe you didn't have it memorized, but they are giving it to us in sentence form. So let's write that in. 400 is less than 1/2 base times height of the triangular base multiplied by the height of the pyramid, and then multiplied by 1/3, because we know that it's 1/3. And that's like the most awkward way I've ever seen this formula written down, so I want to write it down for you in a different way. Just give me a second, and because I want a diagram as well. Oh. Okay, that took a minute, but here. So here I've drawn a triangular based pyramid, which happens to have a right angle in it. Okay, so it's right angled at B and H1. H1 is like the height of the base. Okay, and then, so that was in the darker blue color there. And then the lighter blue color is the stuff that comes up three-dimensionally, and its height measured at a right angle to the base is height 2. And so then I have, here's the area of the base, right? Like base times height on 2. That's just the area of a triangle. Okay, multiplied by the height of the whole thing, multiplied by 1/3. Okay, when objects taper like this works for cones, this works for pyramids. Whenever they taper, they have 1/3 the volume of an object that doesn't taper. Okay, so you'll practice that in the future, I'm sure. All right, so now let's continue on with our work with this formula. We want that to be less than 800. So let's consolidate everything that we can. 1/2 times 1/3. Okay, so we're going to have 400 is less than 1/6. That's 1/2 and 1/3 multiplying. Base times height times the other height. Well, base will be x plus 1, height will be x, and other height will be x plus 1 on 2x. So those are the three things that we're going to be using in our formula there. So base is x plus 1 multiplied by x multiplied by x plus 1 on 2x. And that's got to be less than 800. Okay, let's keep going. All right. Now, inside there, we can still simplify all that stuff, right? Like we can say, well, these x's will cancel. Pow, pow. Okay? All right, so let's go. We will now have 400 is less than, let's do this 2 multiplied by this 6, so that's 1 on 12 times x plus 1 times x plus 1. Okay, so x plus 1 is some number squared. And if you know how to do x plus 1 times x plus 1, good for you. You can do that. I'm not actually going to do that here because there's a shortcut that allows us to avoid having to multiply that. Okay, so now I see that 12 on the bottom. Let's multiply everything by 12. Okay, just get rid of it. Okay, so we're going to multiply this by 12. We're going to multiply that by 12. We're going to multiply that by 12. Okay, I'm sure it's okay. I'm sure it's okay with you. You just loved that move. So that's 4800 is less than x plus 1 squared is less than, that is 96. Yeah, 9600. So now I'm looking for the number of squares between 4800 and 9600. That's all I need to find, the number of squares between 4800 and 9600. How the heck am I going to find that? Well, I could just start cranking them on a calculator, or I can do this. I can say, well, let's take the square root of all of these things. This is like a nice way to do it, actually. I was going to essentially do that, but this is a nice way to show it. I can take the square root of every element in here, and it's going to be fine. It's going to work. Okay, so now we've got 4800, but I take its square root, so that's 69.2 is going to be less than x plus 1 is going to be less than 9600. Where is it? 9600, but I take its square root, 97.9. Count the number of x values that will make that true. Well, x here could be x could be as small as 69, and that would make the inside in there 70. Okay, so that would definitely be bigger than 69. All the way up to the largest value of x that we could have is 96. That's a kind of cool number trick there. So now let's count how many numbers are there between 69 and 96. It will actually be 96 minus 68 is the number of numbers that are there. So let's do that. Why did I minus 68? Excuse me one moment. So the reason why I subtracted 68 and not 69 is because 69 counts. Like we want to start counting at 1, not counting at 0. We want to make sure we don't get fence posted here. So I can borrow 1, that's a 16, and so then that's 28. So 28 is the number of values of x that will give the weird pyramid shape a volume that's between the two values. And that's how you can approach a problem like that. And 28 feels like a reasonable number of values. And also, if we go up to our diagram, we're still inside the pyramid in a lot of places, right? Like if we go x is 69 or x is 96, we're going like pretty far out in there, pretty like up. We never get very high, but we do go out and we get the correct volumes. So that's how we can approach this type of problem. Any questions, hit me up in the class, but otherwise, thanks so much for showing up for your learning, everyone.